pretty powerful these days.
Yeah, I'm pretty sure most of us use like some sort of, ChatGPT, Bard, or like whatever your favorite browser is.
They're getting even more powerful, like video capabilities,
Mm-hmm.
a bunch of other stuff.
I mean, it's incredibly hard to avoid. Like, even if you use Google, like, the first thing that pops up is their AI.
Yeah, there's Microsoft Copilot on Edge.
Even Canva has AI now.
Oh, yeah.
Auto-generate
Everything
like posters for you.
Yeah.
You don't have to do anything.
So many movie posters and like images these days are all AI generated.
It's hard to tell like what's human made and what's AI made. It's kind of
Sometimes
scary.
that's okay. I mean, like, it's efficient. If you can have AI do the menial tasks, you can do everything else.
That's true.
Yeah. And I mean, even before the current like ChatGPT and all this stuff, there was still like neural network AIs, and those were more powerful than anything a human could do, right?
Exactly.
And that's also progressing. So.
Let's talk about that. How is it progressing?
Like all these neural networks and stuff, like how do they even work?
Well, I mean, they're all built on the foundation of MLPs, or multi-layer perceptrons, in which, I'm pretty sure everyone out there has seen some sort of representation in which you have, like, nodes on one layer, nodes on another layer, nodes on the next layer, and then you have, like, lines
A bunch
connecting.
of like lines connecting them, yeah.
Kevin will throw up an image.
Yeah.
And so essentially, what this neural network does is it trains. Well, first of all, each node is basically a linear function, like y equals mx plus b. Well, plus an activation function. But so essentially, what this y equals mx plus b is, it takes the input from the previous node, scales it by a certain factor, and then adds a bias. And the scale is the weight, and the bias is, well, the bias. And what this MLP actually does is it trains the weight and biases to best represent like the hidden function of the data to get your best output.
Mm-hmm.
Yeah, but the tricky thing about MLPs is that you can't exactly access the middle layers, right? You can only put in your inputs and you get what the thing churns out.
Yeah,
right?
it's been a problem. Like other models, like like linear regression, you can easily extract your features. Like your top feature is highly correlated. It has this whatever slope, and like, oh, if it goes up by this much, then your output goes up by this much. But for your neural networks, you have your inputs and you have your output. It doesn't matter if you're getting perfect outputs. Like, it's pretty tricky. Well, in the past, at least a few years ago, it was impossible to tell like which feature actually contributes to output, even though it performs better than your traditional machine learning models. Yeah, so one paper actually came out recently, a month ago, that kind of changed the fundamental MLP. And what this is called is, it's the Kolmogorov-Arnold Network. And what this is it's based on the Kolmogorov-Arnold representation theorem. So, okay, let's just backtrack a bit. So neural networks, their goal is to have a set of inputs, learn the underlying hidden function that maps the inputs to the output, and of course get the best output possible. And what these researchers thought about was, okay, there's an underlying function. It's math, right? And what this Kolmogorov-Arnold representation theorem states is that any function can be decomposed into a sum of smaller functions. And so essentially, it's pretty intuitive. You just train a bunch of functions on your inputs and then combine them to get your output, right?
So basically what's cool about this Kolmogorov-Arnold networks, these things, is that you can represent your whole you can represent your whole like network with a mathematical function, right? Some of all your activation functions. And why is that important and cool?
And better.
Because it's a lot more accurate than traditional
Well,
neural
because it enhances interpretability, as we said. So neural networks, they can no longer be a black box where you can't see like the inner workings. So before it's just input, it goes in the box, you get an output. But now you can actually see like into the inner workings, see, oh, this input maps to a certain function, which is mapped to the next function, and then you can visualize that. And then at the end, you can have basically an entire mathematical function mapping your inputs to your outputs.
Basically breaking everything down.
Yeah.
So how does that help in like a real world scenario?
Yeah. Well, this is still in the early stages. So they've only, I'm pretty sure they definitely didn't test cans on the scale of like ChatGPT, these LLMs that have like 18 billion parameters.
Mm-hmm.
These were more smaller scale, and they tried to map like simpler mathematical functions like e to the sine x plus cosine x2, stuff like that. But it does have better scalability, because if you think about it, there's so many weights and biases you need to train in these traditional MLPs, and for this one you only need to train a function for each input. And what they found is it actually scales better. Well, it trains a little slower, but otherwise it scales better as you increase the number of parameters.
Cool. So we can expect in the future to be seeing a lot more of these.
These cans.
Yeah, I mean, we'll see. Like the week it came out, there are like so many videos going out on YouTube. Like, are cans the future of machine learning? Like, oh my God, are they going to replace traditional MLPs? But you know, we'll see. Like, it needs further testing, and this paper, although it showed that they were better at certain tasks, it was a smaller scale. So I guess we'll just have to see where it goes.
Exciting.
Yeah, only time will tell.
Well, if you're excited about cans, leave us a comment down below and tell us how excited you are.
Yeah.
Ooh. Use a bunch of exclamation marks.
I'm not sure if there's like a can emoji, like a tin can. But if there is, drop it down below.
That's clever.
Or like a soda can. I'm sure there's, I think that's one.
They're more generalizable on a smaller scale, but we'll have to see as they scale up.
Super
I'm
awesome.
sure they'll figure it out.
We've uncovered AI.
Yes.